In this podcast, we're going to talk a little bit about stoichiometry. Stoichiometry is something that you did in regular chemistry, and I'm sure you studied it extensively. So I'm just going to remind you a little bit about what it's about. All right, basically, the greatest thing about stoichiometry is that you have to be able to reason backwards, as you see from this quote from Sherlock Holmes. That's one of the most powerful things about stoichiometry is that you have to be able to reason backwards in order to solve problems. All right, a little review. Okay, basically when you have a chemical change, you have a reorganization of the atoms into one or more different substances. So we always satisfy law of conservation of mass. The left side of the equation is the reactants, the things that come together in the beginning of the reaction, and what's produced is the products. When you balance the equation, it has a lot of quantitative significance. So you can use the coefficients in front to help you solve problems and convert from one substance to another. So you have 1 mole of ethanol, 3 moles of oxygen that react to produce 2 moles of carbon dioxide and 3 moles of water. So there is definitely significance in those numbers in front when you balance an equation. When you want to solve a stoichiometry problem, there are a couple of steps you should look at. First, you should balance the equation. Second, you need to convert your mass or volume, whatever you're given, to moles if that's necessary. If you started with moles, you don't even need to do this step. Then you're going to set up your mole-to-mole ratio. This is going to be what's going to enable you to use the coefficients from the balanced equation to get from one substance to another. And then you're going to calculate the moles using the mole-to-mole ratio, and then you're going to convert those moles to mass or volume if that's what you need in the problem. All right, here is an example. So we have 6.5 grams of aluminum reacts with excess oxygen. Wants to know how many grams of aluminum oxide are formed. You will have to learn to write equations. So aluminum is just Al. Reacts with oxygen. Remember, oxygen is diatomic, which is why it appears down here as O2. And then it forms aluminum oxide. We get the formula because aluminum is 3 plus, O is 2 minus, and then when you swap and drop, you get Al2O3. You then must balance your equation by adding these coefficients in front to ensure that you have the same number of aluminums on each side and the same number of oxygens on each side. Reactants, again, are the left side, products are the right side, and then the coefficients tell you the mole-to-mole ratio. So let's do a little practice. Okay, so I always like to start my problems by writing what I have underneath. Well, maybe. All right, so I know that I was given 6.5 grams of aluminum, and I'm trying to find out how many aluminum oxide in grams was made. Okay, so these will just be my reminders up here. All right, so you're going to start with what you're given. You always start with what's given. All right, the first step was convert it to moles. So first thing we're going to do is convert it to moles. So we're going to use the molar mass of aluminum on the bottom. And that is equal to 1 mole of aluminum. Okay, so your grams went away here. All right, now we want to use our coefficients to get a mole-to-mole ratio. Well, we know we have 4 moles of aluminum from the balanced equation. Okay, and we're trying to find aluminum oxide. So we're going to use 2 mole. Okay, and that cancels out our moles of aluminum. And now lastly, we've got to get to grams of aluminum oxide. So we're going to have 1 mole Al2O3 and then the molar mass of that. I skipped ahead and already calculated it out for us, so it's 101.97 grams. All right, now you're going to multiply everything on top, divide by everything that's on the bottom, and you should get 12.3 grams. Okay, so stoichiometry is really all about converting units. Remember, to go from substance to substance, you have to be in moles. That's your mole ratio or your mole bridge. And that's basically the hardest part of it all.